Hello and welcome to today's seminar in the Smart Mobility Connection series. My name is Carly Benhart and I am the 2019 Women in Transportation Fellow for Traffic 21. The Smart Mobility Connection series is sponsored by the Traffic 21 Institute and the Mobility 21 University Transportation Center as an opportunity for faculty to showcase their current transportation projects. It is also an opportunity for students, fellow faculty, deployment partners, and the broader community to engage and network with researchers, highlight opportunities for involvement, and foster future interdisciplinary collaboration. Please note, this session is being recorded, and all participants' microphones are muted. To ask a question, please send a message through the chat box. You do not need to wait until the end of the presentation to send your questions. Now I would like to introduce today's speaker. John Peha is a professor at Carnegie Mellon University in the Department of Engineering and Public Policy and the Department of Electrical and Computer Engineering. He has served at the Federal Communications Commission as Chief Technologist, in the White House as Assistant Director of OSTP, in industry as CTO, and in Congress. His research addresses technical and policy issues of information and communications technologies. He is an IEEE Fellow and an AAAS Fellow. Please help me welcome Professor John Peha as he tells us about his University Transportation Center project, Spectrum Policies for Connected Vehicles.
Okay, I have been unmuted, which is always dangerous. So I'm going to talk today about spectrum policies for connected vehicles. As you heard, I'm John Peha from Carnegie Mellon. So maybe a slightly unusual talk. 3 pieces to this talk. I am going to give you an overview of the state of the spectrum policy debate for intelligent transportation systems, or ITS, and sort of what the agencies have been doing. Then I am going to bounce to some technical analysis that we have done and results we have achieved related to some of the issues in that debate. And then I'm going to bounce back to a more policy-oriented proposal that has come out recently and is hopefully gaining a little steam. So first of all, what on earth am I talking about? Connected vehicles are the wireless communication systems for vehicles. That is, they allow vehicles to communicate with each other, vehicle to vehicle or V to V. They allow vehicles to communicate with roadside infrastructure, V to I. They allow vehicles to communicate with all sorts of things, pedestrians, cyclists, whatever you would like them to, which we call vehicle to everything, or V to X. And I'm going to throw around the phrase V to X a lot in the coming talk. Here's a picture I stole with a language I don't speak, but shows you that cars can communicate with each other and cars can communicate with things there by the road. This doesn't have to require any cell towers or cellular infrastructure to work, which is important because cell towers are expensive. But if you happen to have them, that can add to the picture and can be useful for some things. So let's first talk about the spectrum policies for V to X. And in particular, in 1999, 2 decades ago, the FCC put aside spectrum for what was then called, and is still called, Intelligent Transportation Systems, ITS. They put aside 75 megahertz of spectrum in a band pretty close to 5.9 gigahertz. It was exclusive, that is, you could only use it for this V to X stuff. And they specified the technology, which is something called DSRC technology, which emerged from the IEEE standards bodies. Sort of, it is a cousin of Wi-Fi, if you like. Looking back on over the years, there's been some activity, but it has been pretty limited. Car companies did not all rush out and put this DSRC technology into their cars. Municipalities, for the most part, didn't build extensive roadside infrastructure. There have been some deployments, but it is not wide scale at this point. And also as background, before we look at things changing, 6 gigahertz spectrum has become increasingly valuable since 1999. Back then, it would have been considered pretty high frequency. Now it is. There are a lot more systems that might want to use that spectrum. Most obviously, right next door is an unlicensed band that is useful for Wi-Fi and other things. So by 2013, the FCC, noticing that the ITS band is not heavily used, they launched a what's called a notice of proposed rulemaking, a proceeding on it was to consider sharing this ITS spectrum. We'll still use it for V2X, but maybe the band can be used for something else too, and they will share. After a number of proposals came forward, and 2 emerged that had the most support, which you can see in this slide here. The gray is the neighboring band of unlicensed, and then the blue is the portion of spectrum from 5.85 to 5.925 gigahertz that is ITS. And in one of these proposals, but you still have to protect V2X. You still have to make sure it's going to get decent quality of service. So how do you do that if you're going to share? Then the first proposal says, all right, we'll share the whole band, but we will give V2X higher priority, and in particular, if the unlicensed devices that are going to share the band are going to have to listen, and they're going to have to make sure they haven't heard any V2X for a long time, seconds. That's a long time in this world, and only then can they transmit. Which means you'll get plenty of transmissions, for devices that are not near roads, but near roads you'll probably see enough activity that these devices won't be able to get the spectrum very often. An alternative said, all right, let's just carve this spectrum band into pieces. One piece we will not share, so we will protect the V2X in that band. The other piece we'll share, and we'll share under more co-equal basis. We will not require the unlicensed devices to only transmit when they haven't heard any V2X for a long time. There are pros and cons to that, which I won't get into, and actually the FCC, as a lot of industry groups, as well as eventually the FCC, began testing both of these sharing approaches. Now that's the action at the FCC. Now let me switch over to the other. The FCC is the agency in the federal government that handles spectrum for everybody other than the federal government. So obviously they're a player. Department of Transportation, also obviously a player. They care about transportation, so they're going to care about intelligent transportation systems. In the Obama era, particularly at the end of the Obama administration in particular, the Department of Transportation proposed a new approach. Said, all right, we're going to build on what the FCC did, but if everybody's not deploying this DSRC stuff, let's put out a mandate, just like we do with seatbelts. All new cars in this country should come with that equipment, and we will urge state and local governments to go out and deploy infrastructure that works with it. We won't necessarily fund them to do it, but we'll urge them. So that was what was proposed in 2016. And the Trump administration decides to go the opposite direction, or at least a different direction. They say, all right, we don't like this this mandate. We're not going to do that. And we're no longer explicitly backing DSRC, even though that, which has been the technology since 1999. There's a new technology called cellular V2X. Maybe we'll think about that, but we're not backing it either. We're just not explicitly backing a technology. And finally, the action returns to the FCC. And at the end of 2019, in December of 2019, there is a vote at an open meeting that says, let's consider yet a new approach. Instead of the sharing that we've been looking at for a few years, what if we just take the ITS band and we shrink it down? We reduce it from 75 megahertz to 30 megahertz, and either it will all be this new technology of CV to X, or maybe 2/3 of it will be CV to X and 1/3 of it will be DSRC. And note that the testing of those spectrum sharing ideas that I just presented is still underway at this point, but they said, maybe we don't want to do that anymore. And so they voted to do this in December of 29 to launch this proceeding in 2020. Meanwhile, I went to DC to be in the room for this this vote at the FCC, and interestingly, a mile away at the Department of Transportation that week, they were also holding a public event, which was to discuss, which was to publicly emphasize the importance of needing 75 megahertz, in sharp contrast to what the FCC was doing. And as this proceeding has gone in 2020, we've seen that in their written comments. So what is the current policy on V2X? Why did I tell you all that? It's complicated, right? The FCC's 22 proposed rules being considered in 2020 contradict the FCC's previously proposed rules, including those previously proposed, that were being considered less than a year ago. The Department of Transportation's 2020 proposed rules contradict the Department of Transportation's previously proposed rules. Perhaps more importantly, the two federal agencies strongly contradict, proposals are contradicting each other. And in the meantime, all of this is the federal government. In this country, state and local governments actually build a lot of the infrastructure, or on the commercial side, commercial operators build a lot of infrastructure. And the federal government is kind of presuming that somebody's going to build all the infrastructure, and it's not clear that that is happening. So the future of connected vehicles is really up in the air at the moment. That is where we are. So to that state of play, and actually the FCC, the proceeding I talked about in 2020 is underway right now. So that's where we are. To that, I want to now focus on just one of the I'll present some technical results on just one of the issues that is raised in all of this debate that I just brought up for you. And I'm going to switch to technology. And after that, I'm going to come back to policy and sort of how do we think about dealing with what I just described to you. So, some people once believed, like less than a year ago, once believed in sharing of spectrum between V2X and other kinds of uses. That is maybe not the current state of play, and that as of 2020, the Department of Transportation is saying which should be exclusively for V2X, and we want 75 megahertz. It requires 75 megahertz. At the same time, the FCC is proposing it no longer be shared, but maybe 30 megahertz. So in the remainder or the next section of this presentation, I'm going to consider whether spectrum sharing should be revisited, although perhaps not quite the way it was considered before. So these are some results of data-driven simulations that have been done at Carnegie Mellon in my group. We have developed these detailed simulations. We simulate the movement of vehicles around a city. We simulate the movement of information around a city using, in this case, a DSRC-based network. We're also looking at CV to X-based networks, but I'm not going to talk about that in this talk. Of Wi-Fi hotspots. We're simulating Wi-Fi hotspots because I want to talk about sharing, and they're an obvious thing to share. And they simulate at multiple layers. We simulate signal propagation at the physical layer. We simulate link, network, transport level protocols, the words. And we feed our simulation with empirical data to establish a baseline. Collect data, say this is what our baseline is, And then we use the simulation to vary from the empirically gathered data, because we find that the cities from which we gather empirical data get unhappy when we tell them to, say, turn off half their devices. But we can do that via simulation. Okay, there's two kinds of traffic here. Well, I oversimplify, but I can consider traffic that is both safety critical, that is, lives may depend on getting it right, because this has to do with cars talking to each other to prevent collisions, and they are latency sensitive. That is, it matters how fast that information comes out there. If we're exchanging information that says, I am about to run into you, latency is kind of important. There is also traffic that is either not safety critical, maybe it's for entertainment. So if we lose it, we lose it. Or maybe it is safety critical, but it's not latency sensitive. You don't care how fast it gets through. And for those things, I care less about latency. I care a lot more about throughput. In this talk, I am focusing only on the latter group, that is not safety critical or not latency sensitive. It's not that we don't care about the safety critical stuff. We do outside of this talk. So I'm going to adopt a sharing model that says, because I'm not going to pay any attention to the safety critical traffic in this talk, it has a portion of the ITS band, and we'll assume it's taken care of. And there's another portion of the ITS band where there is sharing between the non-safety traffic and whatever else you like. In this case, we're going to talk about Wi-Fi as also sharing that band in some manner. And actually, they will share it on a co-channel basis, so it can transmit, even when there is ITS or V2X traffic going around. So there's an exclusive use and there's a shared portion. I'm gonna, we consider a wide range of scenarios. I'm gonna handpick a few results for this talk because we have limited time. And the scenarios, so, we can vary the percentage of vehicles on the road that have this equipment from 25% to 100%. We can vary the mean data rate that these vehicles that are exchanging or receiving from 0.4 megabit per second to 4 megabits per second. We can also vary the scenario with Wi-Fi hotspots in particular. Of importance, we consider systems that have indoor Wi-Fi in our homes, in our businesses, etc., and outdoor Wi-Fi. By outdoor Wi-Fi, I mean sort of municipal Wi-Fi systems. For those of you who are in Pittsburgh, for example, downtown Pittsburgh has Wi-Fi outside, so you can serve people in the neighborhood. So we consider both of those, and we assume that, say, 15% of the indoor Wi-Fi and 100% of the outdoor Wi-Fi is active at any given time. We assume everybody uses TCP. One thing we also assume is that we're not considering Wi-Fi in cars. We're not thinking about hotspots that are inside a car, which is an interesting also possibility. And we vary population density as well, but we're pretty much looking at cities in this work. So here are some results based on all of those assumptions. The x-axis in this graph is the amount of bandwidth that we're talking about, and the y-axis is the throughput for Wi-Fi. I'm going to focus on Wi-Fi performance first, and because this is not safety critical, I'm focusing on throughput as the metric that I care about. There are four curves here. The top two curves are one scenario. The bottom two curves are a different scenario. The scenarios vary in a whole bunch of ways, which are interesting, but it turns out we learn from varying all of those things that the way that is most impactful is whether or not you have outdoor Wi-Fi. So I particularly would say the top two curves are a scenario where there is both indoor Wi-Fi and outdoor Wi-Fi. The bottom two curves, there is only indoor Wi-Fi. And starting with the only indoor Wi-Fi, actually those two curves are almost right on top of each other. You can slightly see the difference, but it's pretty small. Oh, I'm sorry, I haven't said what the curves are. So if you look at those, there's two curves. One of them says, what if you allocate the spectrum for Wi-Fi alone, no sharing? And the other one says, we'll have Wi-Fi and we'll have DSRC. And the curves are essentially on top of each other, which means in this scenario, DSRC does not degrade throughput for Wi-Fi. Now, the upper two curves are same thing. One of them is Wi-Fi only. The other one is same amount of spectrum, Wi-Fi and DSRC sharing, or excuse me, the bottom one would be shared. And what this says is the throughput for Wi-Fi is a little bit less when the Wi-Fi is outdoors, as in a municipal Wi-Fi system. Not a lot less, but a bit less. So that is how Wi-Fi is affected when you share with DSRC. How is DSRC affected when you share with Wi-Fi? So here is sort of the converse of that. Again, the x-axis is the amount of bandwidth we're talking about. The y-axis is, again, throughput. This time it's throughput of the V2X system. And again, for curves, the bottom two look at V2X throughput when you're sharing with Wi-Fi, and V2X throughput when you're not sharing with Wi-Fi, and you have the band all to yourself, and it's pretty close. You can barely see the difference. But that, again, is indoor only. And you think about that. Well, most of those indoor, first of all, indoor means the signals have to travel through walls to get to the roads where the V2X lives. But also, there's an awful lot of indoor hotspots that are just not near roads in the first place, even if you ignore the walls. Up above that, you see a scenario where there is outdoor municipal Wi-Fi. And here there's a real hit. DSRC throughput is less when you share. It's useful to know, but you got the benefits of sharing. So do you come out ahead? Do you come out behind? Here is the graph where we actually answer that question, because you can't tell from this alone. So what I really want to know is, am I better off sharing, or am I better off having separate bands? So we'll check that. The question is, how much spectrum do you need to get a given throughput for V2X and a given throughput for Wi-Fi under these scenarios? And to do that, I need a three-dimensional curve, and I do that kind of with color. So the x-axis says, here is the throughput that I need for vehicle traffic. I'm going to actually use color to show the throughput for Wi-Fi. And the y-axis shows how much spectrum you would need to achieve those throughputs. Now the curve on the top shows how much spectrum you would need if there was separate bands, one for V2X, one for Wi-Fi. The other curve shows how much you would need if they shared, and it's a lot less. It's in the neighborhood of half as much. So we save a lot of spectrum by allowing sharing in this scenario. And in general, I'm only showing one scenario. I've only got one short talk to give, but that turns out to be much more efficient across a broad range of assumptions. The sharing here is simply more spectrally efficient. I think I was going to tell you that there are actually multiple ways to share. We can share in the traditional way based on listen before talk. Or it turns out there are other ways to share where the V2X systems don't just listen before talk and try and coexist, but they're actually more cooperative. The unlicensed devices and the V2X devices cooperate somewhat in order to use the spectrum even more efficiently. But I guess I'll have to leave this as a teaser because I don't think I'm going to fit that in my talk in time. So it's in the paper, but I'm going to skip past it for now, other than to say we looked at other regimes as well. Oh, actually, maybe I will not. So I'm going to skip that piece for now to make sure I get to the last piece. So given the conclusions on whether to share. So co-equal sharing, it turns out, for non-safety critical DSRC communications, that we saw a bit of degradation, especially if there is outdoor Wi-Fi. But given the throughputs, but we can achieve given throughputs in far less spectrum with sharing. So sharing turns out to be a pretty good idea, and we should consider allowing unlicensed devices into the ITS band, despite what both of the agencies that are working on this now say. And something that we're not talking about, we should also consider, having the V2X devices use the unlicensed bands next door, and even expand the sharing further. This looks like a good way to use spectrum. Again, this is only good for the traffic that is not safety critical or is not latency sensitive, the stuff that I care about throughput. We're still going to need some other way to deal with the safety critical traffic, and that's another talk. All right, I will skip the discussion of which kind of sharing we found most useful, but we did reach a conclusion there. All right, so I wanted to spend my last minutes talking a little bit about a recent proposal made on the policy side. So this is published this summer under something called the Day One Project by the Federation of American Scientists that I'm excited about, where they put together 100 brilliant proposals on some policy issues related to science and technology for the next administration, regardless of who wins the election. Either way, actually, certainly with Vice President Biden and presumably with President Trump, whoever is elected is going to put new people in, and they will have 4 more years to get things done. And these are all 100 ideas of what could be done in that 4-year period, and mine made that list and is getting some attention from people waiting in the wings, which I'm excited about. So here is the policy. First, let me start with the problem. All right, the current approach has failed. We are not, we have some of the major actors that need to move in order for connected vehicles to work in this country are waiting for others to go so they can follow. We have others who are not waiting, and they're actually working against each other rather than working with each other. That is not going to work. We can't advance by making decisions piecemeal. You can't make them one piece at a time without looking at the big picture, or in the wrong order. For example, I spent a lot of time thinking about spectrum. You cannot figure out what spectrum regulations will support the ITS capabilities that you want if you have not figured out what the ITS capabilities that you want are. We also can't advance without involving the right players. Government alone can't make these decisions about the products and services that both cellular companies and car companies are going to offer, and they are critical to making this work. The FCC can't make decisions about transportation. The Department of Transportation alone can't make good decisions about spectrum, and the federal government alone can't make good decisions about infrastructure when it is typically the local and state governments that build most of it, unless they change that. So what do we need? We need collective action towards a shared vision, a vision that is shared by all the actors. Oops. Okay, my slide is weirdly out of order. We need a coherent and broadly shared vision. Then we need collective action to move towards that vision. And our collective action, it needs to include all of the federal agencies, at least including the Department of Transportation and the FCC that are currently working against each other. We need to get all of the local governments and state governments involved, many of which are not engaged. We need to get the automotive industry aboard, and we need possibly to get the cellular industry on board if they are going to play a role in infrastructure. And there are reasons to want them on board. I think actually I spoke about that last year. Some of the advantages of reducing cost by having partnerships between the cellular industry and government. But that's a previous talk on this in this series. And we need to do all of that under effective leadership. So the solution, the federal government should launch an interagency task force. Federal agencies here will include the FCC, the Department of Transportation, NTIA, which is a part of the Department of Commerce, probably the National Science Foundation, because there's actual research here, probably OSTP, which is the Office of Science and Technology Policy within the White House, where I used to work, and perhaps NIST, which is involved in standards, and there could be other agencies as well. And we need to create an open, inclusive process to do that, where the state and local governments are there, where the auto industry there, where the telecom industry is there. I want consumer protection and privacy nonprofit groups to be there, and maybe even a few foolish academics like myself. What would this group do? It would first establish a vision of applications that must be supported. We need to think about, what do we want to do in this band? There was a vision in 2019. I don't think that vision is the right vision anymore. Some of the things that we wanted in 2019, in 1999, some of the things that people talked about being important in 1999, we might not need anymore. There may be other ways to deal with them. And other things that seemed like science fiction, like autonomous vehicles, no longer seems like science fiction anymore, especially in Pittsburgh, and need to be brought into our vision in a clearer way. If we know what we're building for, we need to decide on a technology standard. That is something I didn't talk very much about, but people are fighting about the standard without knowing what it must support. We need an infrastructure strategy. And in particular, we need to figure out, what is the role of local government? What is the role of federal government? What are the roles of cellular operators? It is not clear. We need a set of spectrum rules. And finally, how much spectrum, which spectrum, how do you divide it? What are the precise rules in the band? They actually matter. How do you protect this band from interference from other bands? And finally, we probably, maybe this will all then, once you have a vision, maybe everyone will work toward it, but we might actually need to find ways to seed deployment. And one of the things I have proposed is that we might give grants to put this money, federal grants, to put this money in certain kinds of vehicles where it is particularly important, like fire trucks and ambulances and school buses, snowplows. There are things we can start and see where it goes. We can also develop model deployments. And there, I managed to get it in 30 minutes, but I had to skip the different forms of cooperation. I can go back if there's use, but I said I'd do this in 30 minutes. So with that, I will open it up to questions.
Okay, the first question, what are the non-safety critical DSRC communication envisioned?
Non-safety critical can be all sorts of things that you can use this band for. Some of them, well, actually, I'll start with, some of them really matter for safety, but you're in no rush. For example, I may need to get a new security certificate. I don't need it this millisecond, but I do need it. Some of the uses of this band may include better managing the flow of traffic through a city. Communicating with signal lights, we can do these things with sensors, but we can do even more with communications. Some of it may be sheer entertainment. Maybe I will get information, or I'll stream videos. I'll check my email. Particularly if we have autonomous vehicles, we'll have bored people in the car. Maybe I will download a map. There's construction in this area and it's changed since yesterday, and I will download a big map. I can wait a few seconds for that. It is not safety critical that I get that map immediately and feed it into my dashboard. So lots of different things you can do. The only things I would take off the table are things that involve preventing imminent crashes, like don't turn left or a car will hit you.
Okay, what impact will reducing the bandwidth have on the safety critical communications if there is across the board deployment?
We will have both safety critical and non-safety critical communications. So it's, we actually need both. We do need to do this in a way that makes sure there is either, if you dedicate spectrum to safety critical, that you dedicate enough of it. And if you don't dedicate it, if you mix it all together, that you have ways of protecting the quality of service of safety critical. And there are ways to do that. I can have a control channel that makes sure that, that where we intelligently allocate the safety critical system. So there's a way we do have to do that. That is a non-trivial task. It is not a task I addressed here. I don't think we know how much spectrum we need for some of those safety critical applications, precisely because I don't think we know well enough what they are, and that we haven't reached consensus on what all of the things that may be needed in the future. We have some ideas of the things that we needed in 1999, but I think it is worth revisiting what we will need in the future.
Okay, given the cost of building out DSRC across the country, isn't it extremely unlikely that the country will prioritize this type of infrastructure?
You never know what people will, there are lots of things we don't spend money on and lots of things we do spend money on. Let's start with, 30-some thousand people die in car accidents every year. And there are a lot of injuries and a lot of property damage that go beyond the actual fatalities. Just on purely safety grounds alone, if you can prevent a significant number of those crashes, there are big savings to be had. So that, this is what the Department of Transportation did a cost-benefit analysis. You can believe it or not, but their conclusion a number of years ago was that just preventing those crashes alone made this worthwhile. Again, I would like to upstate that analysis in lots of ways, but there is motivation to do a lot of this. And that's just the safety aspects. There are other aspects as well. I also think there are ways to drive the costs down. And one of those things might be coming up with useful partnerships, in that cellular operators that want to deploy the latest technology need to build a lot more cell sites in the coming years. And if we also need to build systems for this purpose, then there may be opportunities to make the building of these sites a lot less expensive. But whether we will invest the money or not is, whether the policy wonks need to do the cost benefit analysis. There are times when we do not do things where the benefit greatly exceeds the cost, and things where we do things where the costs greatly exceed the benefits. So we also need the political will, which is yet another reason, actually, if I'll come back to my policy proposal, we need to get everybody to the table. The idea that the federal government, from just a process perspective, the federal government will make decisions assuming that local governments spend a lot of money without listening to local governments does not make a lot of sense to me. We need an inclusive process, and we don't have one yet.
Why would we not reserve spectrum for ITS and potentially release to broader use later? It will be very difficult to recover spectrum for ITS if it is open now, especially since we don't know how much spectrum we will need for safety and for traffic optimization.
So I actually, I agree and disagree in the, well, the idea, if you're saying it is true, if we reduce the amount of ITS spectrum we need, and then we decide we need more later, without having a plan to get more later, that will be really hard. We need a plan. Now, the question of whether we can give some up is separate, but we need a clearer plan and clearer analysis of how much we need before we make these decisions that are hard to reverse. It is also possible, by the way, if we could give up some of this band and replace it with spectrum from somewhere else. That is not impossible to do. But again, one needs a plan. I'm not going to tell you I know what the plan ought to be, because I'm actually pushing very hard for a process that doesn't presume anybody knows the plan in advance. Doesn't know the right plan in advance. But I strongly would agree we need to do the analysis before we make decisions that are very hard to reverse.
If we do not know how much bandwidth we need for safety critical functions, why should we be pushing ahead to share the spectrum which has already been dedicated?
We should be, what I have said so within the technical portion of the talk, my argument is that sharing between non-safety critical and unlicensed is a very spectrally efficient thing to do. So I didn't actually, in that portion of the talk, comment on, or suggest that you would share with safety critical, or comment on how much of it was. So I wasn't arguing we should move ahead or not move ahead in this talk. And if you ask what I think more generally, it is, I think we need to do the analysis. We need to do the analysis, including the traditional kinds of spectrum analysis that the FCC normally does, but fed with information that has to come from the transportation sector, and including, cost benefit analysis that the FCC is not typically doing, but it includes both sides. So yes, I think we need to look before we leap. And from an analytic perspective, as well as building consensus, because even if we had the numbers exactly right, if we need broader consensus to make it work.
What types of infrastructure do you foresee within the built environment that may affect how we design and engineer in the future?
What types of infrastructure in the built environment? I'm not sure what you're referring to. If we, maybe that means, where I am deploying devices that, actually, it could mean that in terms of where the transmitters go, or it could mean that in terms of things that interfere with these communication systems. I'm talking about the transmitters. To the extent that we are building new infrastructure that requires some kind of backhaul for any purpose, we can make that multi-use and consider combining these vehicular networks with that infrastructure. And by we, I mean anybody. There will be municipalities building out infrastructure that includes sensors and backhaul for all sorts of reasons, for public safety reasons, could be for environmental monitoring reasons, all sorts of things you might build those devices. There will certainly also be cellular companies who need that kind of infrastructure. And if that infrastructure is getting built, we can consider ways to combine efforts in ways that may be more cost effective. Actually, I'm not assuming everything will be more cost effective. It needs analysis. Sometimes it turns out not to be, but I do think there are opportunities. Guessing that's where that question was going, but I may have misunderstood the question.
You propose an interagency task force for everyone to coalesce around a shared vision. Will the diverse stakeholders achieve consensus just by talking? Do their priorities make that possible? Or will someone above need to impose a compromise?
That's a great question. So there are, in some places, there are differing views. And it may take some leadership to, we may be able to work out compromises. There are a few issues, there are lots of issues where, in fact, any solution is better than no solution, which makes me think that sitting around and talking may help a lot. There are other aspects of this that are really zero-sum games, where there are winners and losers. And you're right, well, implicit in the question, that to get past those, we may actually need somebody who can make decisions. And that has been a problem, right? DOT and FCC throwing documents past each other doesn't do that. An obvious entity, there are other ways to do this, but an obvious entity that can help when there are agencies that do not agree on a consensus is to involve the White House. Up to a point, the FCC is still an independent regulatory commission, but there are ways to bring leadership. And how much of that is needed and how much of it will come out, I don't know. We need to put the task force together and see what happens.
Great, that was all of our questions.
Okay. Well, thank you all.
All right, thank you, John, for sharing your work. And to all of today's attendees, thank you for joining us. As I mentioned earlier, today's presentation will be posted on the Mobility 21 What's Happening page of the website, along with a link to the video of the session. This afternoon, you will be receiving an email asking you to take a short survey about today's SMC. Please take a few minutes to provide your feedback. For students who are interested in engaging with transportation topics, the Transportation Club on campus is a great way to plug into transportation topics with fellow transport nerds. Again, thanks for attending today, and please feel free to contact us with any questions.